Okay, everyone. Today our topic is the connection between music and math. And before we go there, let's refresh our mind to understand the concept of the math. Well, as you can see here, these two Chinese words. These two Chinese words stand for the math. And this stem called Su is stand for numbers in Chinese. So you can find out that math is in Chinese is a kind of science of numbers. And you can find out that it's numbers plays a very important role in math. Pythagoras said that number is the key to the universe. But I don't think math can explain everything all over the world, but it does have a very special positive position in many aspects. So the most obvious aspect is the math and physics. Scientists use math to find out the speed of the light, which is 299,792,458 meters per second. That's so fast. And because the math data show that no matter where you calculate the speed of the light, it retain constant, and so that and based on this, Einstein created a realistic theory of the relativity, which is deeply influenced our daily life. Well, this is the connection between math and physics. So what's the connection between music and math? So let's go on. So here we go. Pythagoras, the amazing Greek, get the credit that discovered the octave, and which is influenced deeply in our musical theory that we use nowadays. And the musical theories like octave and rhythm are also strongly related to the math. Well, in this part, in the musical theories, I will invite my friends to explain to you.
Hey guys, hello, I'm Wee Seng. So today I'm going to talk about the metronomic tempo. So tempo is basically represented the speed of a music playing. You guys know, listen to the music, there are different tempo of music such as fast song, a slow song, a romantic song, or a hip hop song, or a rock song, whatsoever. There's a lot of songs, and their speed is different. Okay. Today I'm going to teach you guys how to calculate the times played for music, the total time needed to play for the music. So you guys can calculate using this formula, the beats times number of bar times 60 seconds divided by the tempo beats. So you can just substitute the value into this simple formula, and you can get the time needed for the music to play. So I give some simple examples for this upper part. Okay, you guys can just substitute the beats. Beats is meaning that the value of a ratio, the upper part. So you look at this is the a 4, so you just substitute 4 times the number of bar. How you know what's a bar? Bar is meaning that when there's a 4 bits in the line, you cut it, and you can just simply find the bar. When you see the sign, you cut like this, then from here you can see that there is a 3 bar. So you just times with 3 and times with 60 seconds times by 60 seconds, then you divide by the tempo bits is meaning there's 100 days, so you divide by 100 and you get a 6.2 second. 6. That's 7.2 seconds, sorry. Thank you for reminding me. You are such a good student. Okay, so now I'm going to give a second example. So as you can see, that these two symbols is different, so your calculation maybe some is different, so you still use the substituting method to this formula. So you can calculate by, you see the bits meaning the upper part of it, this is 2, so you just substitute 2 times the number of bars, so you calculate how many bars is there, 1, 2, 3, there are 3 bars, so times with 3 and times 60 seconds. And you divide by tempo bits, the tempo bits is 100, so easily you divide by 100 and you get the time. I don't know what is the time, so you can calculate yourself. And now you guys can go to find the music score whatsoever, you can calculate the songs of the speed of the music by yourself. That's all from me. Thank you.
Hello everyone, my name is Zhong Qi, and for now, we will teach you about time signature. So first of all, what is a time signature? Time signature is something that tells you how the music is to be counted. So example of time signature is like just now you have seen before, like 4 4 or 3 4 or many or 6 yeah. These are some of the examples. So I will take this as an example. Like in this time signature, this is the top number and this is the bottom number. So basically the top number represents the number of bits per measure. And most often the numbers for the top is fall between 2 to 12. Yeah. And for this bottom number, it represents what kind of knot to be counted. So the common bottom number are 2, 4, 8, 6, and 16. And each of these numbers has their own knot value. For example, this 4, its value is this one, and for 2, its value is this one. So how can this value be derived? Now I will show you how can the bottom number be derived. Wait. Yeah. So now let us look at this diagram. This is the whole knot and this is half knot. So I will just write down the value. This is 1 and this is 1/2. This is 1/4 and this is 1/8. Yeah, so this knot has their own value. So for the example just now, this 4/4. The bottom number is 4, right? So it is represented by these two knots because for this, if the bottom number is like 2, 2, and this 2 is represented by this. So the top number means there are two this kind of knot in one bar, and for this there are 4 of this knot in one bar. So this is very easy, right? Okay. So I will show you some example like in the music score. And this 4/4. 4, the button. First you need to determine what is the note for this. So for this 4, the note is this, right? It's this. So the upper 4 means there are 4 of this note in one bar. So you just write like this, 1, 2, 3, and 4. Yeah. So basically it's like this. So if the time signature is 4/3, the 4 is still same, it's still this note, this quarter note, and the 3 means there are 3 of these in one bar. So it's like this. This is one bar. So this is it. Okay.
Okay, hey guys, I'm here to talk to you about the connection between frequency and math. Okay, what is frequency? Frequency in physics is the number of waves that pass a fixed point in unit time. Okay, when two notes are played together, they either make a dissonant or consonant sounds. Dissonant happens when two sounds are unpleasant to hear, and consonant produces nice sounds. Ancient Greeks have discovered that only integer multiples of frequency of a given note can be combined to make consonants. For example, a given note of 220 Hz makes a consonant sound when played with notes of frequency 440 Hz, 660 Hz, or 880 Hz, and so on. Simple multiplication can produce a fine sound. In ancient Greek, Pythagoras discovered the relationship between harmonic ratios and proportions. He realized that when a blacksmith hit an anvil with his hammer, it created different tones according to the weight of the hammer. So Pythagoras continued to study this and discovered that different proportions of string length created different proportions of frequencies, especially consonant tones. He divided a string into halves and compared the sound to the original string and the divided string. He found that the divided string was exactly an octave higher than the original string. He also noticed that the divided string vibrated twice as fast as the original string. Okay. Now, music involves trigonometry as well. Sound is created by something that vibrates. Therefore, when a string is plucked, the string vibrates and produces sound. The string can be expressed as waves by a function of sine. Y equals A sine 2 pi f t. Okay, where t is time, f is frequency, and a is amplitude. The graph will, okay, let's say this is a graph of a middle C. Okay, which has a frequency of 256 Hz per second. Okay, to get a frequency of C that is an octave higher than the one shown over there, one has to double the frequency because the ratio on an octave is 1 to 2. So substituting 512 Hz as frequency into the function will produce a graph of C that is an octave higher than middle C. So the graph will look like this. Thank you.
Okay, now I'm going to show you an example of how the length and thickness of the string will affect the frequency. Now, for example, this original string length, as you can hear. Okay, for this, we take it, for example, 500 Hz. Okay, so, but when this original string length is halved, you can hear that the pitch is higher, so which makes the frequency twice as high, so it's about 1000 Hz. Now, if you take the thickness if you take the thick string, you can hear that the pitch is very low. And when you take the thin string, you can hear that the pitch is high, so it means that the frequency is higher compared to the thicker string. So that's it.
Hi, my name is Kenneth. Okay, so as a continuation towards what my friend Zihao has said just now about time signature, I'm going to explain more about it, and also I'm going to explain about rhythm, intervals, and also chords. So, what is time signature? Time signature is the pulses that are grouped into a few single sessions. And what about rhythm? Every single song you hear, you know that they'll say there's a rhythm of it. So, what is a rhythm? Rhythm is the moment where notes, chords, and other musical sounds begin and also end. So practically every single song you hear, you know there's a rhythm. So what's the importance of time signature and rhythm towards us? It determines the feel of the pulse and rhythmically lead to the music. Furthermore, it also makes the music sound better. If without the rhythm, the song would be a disaster. So, what about interval and chords? Chord is a group of typically 3 or more notes sounded together as a basic of a harmony. So, what's the importance of mathematics in chords? It is an analysis of melody and harmony in music. For example, a C major, over here you can see, chord is made up of the notes C, E, and G, with C being the root. So, C is the root, you can see E and G, and then it makes up the C major over here. So, what's the effects of studying music towards everyone? Okay, it raises the IQ level of each person. So, if you have learned music in your life before, you have a higher IQ level compared to other people, normal people who has no music background. Furthermore, it also improves creativity and also improves your test score. Now, I'm going to talk about Mozart effect. Well, what is Mozart effect? It's a listening of music that will make you smarter. It's true, the music does make you smarter, especially when you listen to composers such as Mozart, Vivaldi, Pachelbel, Handel, and Bach. Okay, so research has been carried out by the college entrance exam. Students who play or sung music in their life has an average score of 39 points higher than normal people who present math. So this really proves that math has helped increase your level. Music has helped increase your level in